Hey guys, this is for measuring volume and calculating density. So just watch this video if you need some help or a review on how to solve for some of these problems. All right, so first we're going to talk about volume. So volume is how much space an object takes up, and the equation we're going to be using is length times width times height if we are trying to calculate the volume of a solid object. Right. There's other ways to find volume, like volume of a liquid. We can use measuring devices like graduated cylinders or beakers. So the units for volume are going to be in milliliters. Generally, if it's a liquid, it's going to be in milliliters, or centimeters cubed, right? Because we're taking the length, we're taking the width and the height, timesing them all together, and those centimeters times 3 times is going to be a cubed, right? So those are the two main ones we're going to be using for volume. So if you see any numbers with those units, that's its volume. So we have a few practice problems here. So if we're measuring shapes or objects that have clear measurements already laid out, we can calculate. So if we do this one, what is the volume of the cube on the right? So we got to do length times width times height. All right, so that's going to be 12 times 4 times 3, right? And something that things normally would have would be units. So let's say these are all in centimeters. So you take that, you use your calculator, 12 times 4 times 3, and you get volume equals 144 centimeters cubed. And then box your answer. Make sure you show your work. You include the initial equation you're using, and you have the units at the end. Sometimes too, we'll have beakers or this graduated cylinder of a liquid, and we'll have to find the volume using measurements. And the biggest pitfall for measurements is being precise. You want to make sure you're the right amount of precise for the container that you're using. Right? So in this one, where you can be pretty precise, right? Because we have 3 and 4, and we have single digits in between each one. So this is like 3.1, it's like 3.3, 3.5 is in the middle. So if we look at the liquid, remember when we were measuring liquids, we want to look at the bottom of it, or the meniscus. Right? That was something you might have went over when you were in biology class 2 years ago. So the meniscus is the bottom of it, and generally if we just kind of use our eyes, we can also kind of draw it over. That's generally where it would be. So if we count it out, that would be 3.1, 2, 3, 4, 5, 6, 7. So I say that's 3.7. Now, this one would be tough because it's pretty small, but because there are numbers, we can actually do one more digit. And that last digit, when you're measuring something, is our uncertain digit. So we're saying it's 3.7. It could be 3.69, it could be 3.71, 3.72. We don't know for certain, so we use one more digit to kind of show like, okay, that's our rough ballpark. We know it's definitively in the 3.7 range, though, so that's going to be part of it. Liquids are in milliliters, so make sure you include your units. That's the answer. Next, you can find the volume of irregularly shaped objects by putting them in beakers of water. So if we have this solid, we don't know what it is, or the substance, we want to try to find the volume. We put it in the beaker here. So for question A, what is the volume of the liquid in the cylinder? We can see the lines right at 600. So it would be 600 milliliters, right? As soon as you put the solid in, it then jumps up to 800. Right? Does that mean there's 800 milliliters of water in the graduated cylinder? No. It means whatever you added is 200 milliliters, or in this case, 200 centimeters cubed. Because solid objects, generally, we do centimeters cubed for their volume. So because there's a 200 meter difference, milliliters, it went up 200 milliliters, so we can say that the rock is 200 centimeters cubed. All right, and we just did 800 minus 600. And I just converted it to centimeters cubed for solids. and that's volume. So if we look at the next part, density. So generally for density, for this section or lesson, we always have mass, we have volume, and we have density. So the density of an object is its mass of a substance per unit of volume, or a better way to think about it or visualize is mass divided by volume. So the units for density are just combining the units for mass and the units for volume, which is grams divided by milliliters. Okay, so that's our unit. So we have a few problems here. First one, calculating density. Suppose a large chunk of gold has a mass of 309 grams, and I just underline any info that I might need. So it's mass of 309, a volume of 16.0 centimeters cubed. Divide the mass of the gold by its volume to find its density. There's a typo. So we take density equals mass times volume. Substitute in our problems. So 309 grams divided by 16.0. And then we plug it into the calculator and we should get 19.3. So because both of these go up to what we call significant figures, and we'll talk more about significant figures later, they both have 3 sig figs or SFs. So we know our answer needs to be 3 numbers long too. All right, so after 0.3, we stop. This is grams over centimeters cubed. All right, and that's our density. So gold is something that always has the same density. A pure substance of gold always has a density of 19.3. If you had something, well, actually that's the next problem, so we'll go to that. So say you have something, you have a gold ring that weighs 7.5 grams and has a volume of 0.388 milliliters. Do you think it's real gold? So we know gold has 19.3 density. So what we'll have to do is find or calculate that. All right, so we do 2.50 divided by 0.388, and we should get 6.44 grams over milliliters. That's our density. So that's our density. Like I said above, the real density of gold is 19.3. So because these densities don't match, this is fake gold, meaning there has to be some other substance in there that has a lighter density to bring that number down. Kind of big idea of all of this. Each specific type of substance has a particular density. They're not going to change. So you can identify a substance by its intensive properties, such as density. So gold always has 19.3. Copper always has a specific density. Iron, lead, aluminum, they all have specific densities that are unique to them. All right, so a few more problems here. So say you have a piece of zinc that has a density of 7.1 grams per centimeters cubed and a volume of 2.0 centimeters. What is its mass? So this time we need to find the mass of an object. So I just wrote down my givens and unknown here. All right, these are givens. And we need to solve for mass. So we are still using the mass times, or the density equation, mass divided by volume. But now we need to move things around to solve for mass. So we need to isolate mass. And the way we do that is get rid of the volume. And we can do that by timesing volume by both sides. What happens is the volumes on this side cancels out. And then so we're left with mass equals density times volume. We can plug that in, so volume is 2.0 centimeters cubed times 7.1 grams per milliliters. Make sure you include your units in the numbers too when you're showing your work. You need that detail, and if you don't do that, it's a much easier way to get lost and get the wrong unit that you don't need. So we do these two, and we should get 2 times 7.1, we get 14.2. And remember, what are we solving for? We're solving for mass. So the mass for, the units for mass is always grams. Oops. All right, that's our answer. Last one. So you have a piece of copper that has a mass of 32.3 grams and a density of 9.0 grams centimeters cubed. What is the volume of the copper? So this is an opposite. We have mass this time. We have density. And we need volume. Okay, so we go back to our density equation again. Density equals mass divided by volume. And we plug in those numbers, or we solve for volume this time. So what we're going to do is bring volume to the top. These will cancel. Volume is still not isolated, so next we have to divide both sides by density. Now these will cancel out, and what we're left with is volume equals mass divided by density, which will be 32.3 grams divided by 9.0 grams per centimeters cubed. These units will end up canceling out, the grams will. And if you do 32.3 divided by 9, you get 3.59 centimeters cubed. That's our volume. All right, so you can use this video to go back to any problem specifically, and then if you have any other questions besides that, let me know. See you guys.